Yo, 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 yo. All right, everybody, we're going to talk about geometric sequences. So first, let's get into the definition of geometric sequence and arithmetic sequence. So we've already learned about arithmetic sequences. So arithmetic is when we're adding to the previous term, and then geometric, the only difference is now we're multiplying. And we're multiplying by a common ratio. Okay, so that's the difference instead of adding it by a common difference. Okay, so a geometric sequence is now multiplying. So let's just get into it right away. So first you need to be able to identify, is something arithmetic or is it geometric? Okay, so if I looked at this one, my common difference is 1, and then from here, it's not 1, it looks like it's 2/3. And then from here, it's even a different number, so it's not a common difference. Okay, so it can't be arithmetic. Now, if I want to know if it's geometric, what I would do is I would figure out, do they have the same common ratio each time? And that's when we take the second y and we divide it by the second value, we divide it by the first value. So this one would be, the common ratio is 2/3. Right here, I would take 4/3 and I would then divide it by 2. Well, 4/3 divided by 2 is times 1/2. Well, that's going to give me 4/6, which is also 2/3. So I'm taking the consecutive values, and I'm just dividing them. Okay, so 2 divided by 3 is 2/3. 4/3 divided by 2 is also 2/3. And if I notice, that's what's being multiplied each time. If I take 4/3 and I multiply it by 2/3, that's going to give me 8/9. If I take 8/9 and multiply it by 2/3, that's going to give me 16/27. So this would be a geometric sequence, and my common ratio is 2/3 because that's what's being multiplied each time. Okay, so 3 times 2/3 is 2, 2 times 2/3 is 4/3, 4/3 times 2/3 is 8/9. And again, the way we figure this out is we take the values and we just divide them. This would be 4/3 divided by 2, this would be 8/9 divided by 4/3, and all of these are still going to equal 2/3. Okay, now we have to write a recursive formula, and we're also going to have to write a explicit formula for geometric sequences. So here's your formula. So we have our common ratio, and we have the previous term, which is a to the n minus 1. And that's for our nth term. Also, as part of your recursive formula, that's not included in this, so you need to write this part in, is we always need to include the first term as well. Okay, so we always have to include what's the first term, and we have to include what's the nth term. So for example, on this particular sequence, my first term is 8. My nth term is whatever that common ratio is times a to the n minus 1. Okay, because we're taking the common ratio, we're just multiplying it by the term beforehand. Like, so here, if I wanted this term, I would have to multiply this by the common ratio, which is the term beforehand, and I would multiply this by 2/3 to get to my second term. So I need to figure out the common ratio by doing my division. So that would be 12 divided by 8, 18 divided by 12, 27 divided by 18. All of those should give me the same thing. So that would be 12/8. I could have done 18/12. I could have done 27/18. All of these should simplify to the exact same value. This is, if I divide these by 4, I get 3/2. If I divide these by 6, I get 3/2. If I reduce this by 9, I get 3/2. If I actually plug them into a calculator, if I did 12/8 in a calculator, I would get 1.5. If I did 18/12 in a calculator, I would get 1.5. 27/18 in a calculator, 1.5. 40.5/27 in a calculator would be 1.5. So my common ratio is 1.5, or you could also write it as 3/2. Here is my recursive formula. It always will include both pieces of information. Now, looking at the same exact sequence, we're going to write the explicit formula. Now, explicit formula is a little bit easier to use when we're trying to find something like the 10th term in a sequence. So for my explicit formula for this one, we already know it's 1.5, or 3/2 for my common ratio. Okay, so that's right here. So For the nth term, I take whatever the first term is, 8, multiply it by, that's our starting value, right? Initial value, just like in exponential functions. Our common ratio is still the value that's going to be inside our parentheses. That is going to be to the, that's going to be raised to the exponent. So my common ratio in this example, we'll use a decimal this time, is 1.5. But now this is to the n minus 1. So if I wanted to know the 10th term, here's my explicit formula for this particular sequence. Now I can plug in 10 for n. If I want to know the 10th term, whoa, that was weird. If I want to know the 10th term, that's 8 times 1.5 to the power of 10 minus 1. So that's 8 times 1.5 to the power of 9. And this is where I get to figure out, well, what is 1.5 to the power of 9? Oops, sorry, I'm plugging that into my calculator right now. I get 38.443359375. I'm going to leave that in my calculator, then multiply it by 8. That was our initial value. So the 10th term in this sequence, I'm going to round it, is 307.55. I rounded to the nearest hundredth. Okay, that's it. So it's still an exponential function. We still have our initial value as our first term. We still have our common ratio, but the only difference is now we're raising it to the power of n minus 1 because we have to take the term that was beforehand and multiply all these things. Okay. So what I want you guys to do is I want you guys to model this particular situation. The number of subscribers a blog doubles each week. How can the trend in subscribers be modeled? So we want to write this as a sequence. Okay, as a geometric sequence, and we'll write the explicit formula and the recursive formula for this one. So I want recursive and I want explicit. So write both formulas, pause it, see how you do. Okay, so the first thing I want to talk about is how we would write this just as a regular exponential function. We don't have to write it as a sequence if we didn't want to. So if this was just, if I just wrote it as an exponential function, my initial value is I started with 5 subscribers. The constant ratio is 2 because we're doubling it each week, and that'd be to the power of x. This is just a simple exponential function. Okay, well, if we also want to write it as a sequence, I know that this is going to go 5, 10, and it's just going to keep doubling every single week. Okay. And that's the sequence. So the recursive formula would be first term is 5, and then the nth term would be 2 to the power of 8 times a to the n minus 1. So we're just multiplying the previous term by 2 each time we're starting at 5. There's my recursive formula. Explicit formula is going to look really similar to this, right? The explicit formula is we still have an initial value of 5. We still have our common ratio of 2, but instead of to the power of x, it's now going to be to the n minus 1. That's the only difference. Because now I can find after how many weeks, or I can figure out what the nth term of the sequence is. Okay? So 3 different ways to model this. Exponential function, we can write it as a sequence in the explicit formula, which is probably the most useful, and then here's the recursive formula just so we get that extra practice. Okay, so the number of people attending the annual Town International Food Festival has decreased 20% each year since the first year. How can the attendance for the first 5 years be modeled? And if it continues, what will the attendance be in 10 years? So pause it, see if you can model this. Yes, I understand this is a rate, but let's see if we can figure out what that means. And then so see if you can pause it, see if you can try it. If you can't get it, it's okay. We'll give it a shot, make an attempt, and then unpause it. Okay, so I think finding our initial value is probably the easiest part here, because our initial value is just given to us right here. Here is their attendance. So we know our initial value is 1,250. Okay, so now what we got to figure out is we have to figure out what is the common ratio. Well, because this is decreasing by 20%, the common ratio is just your decay factor. So the common ratio is 1 minus 0.2. So our common ratio is 0.8. because that's 80% each year, right? That's their attendance is 80% each year, which is less than 100, which is why it's going to go down each year. It's 80% of the previous year beforehand, and that'd be to the power of x. But if we wrote it as a sequence, it would be a to the n equals 1250 times 0.8 to the power of n minus 1. Now, if you chose to write a recursive formula to describe this, and so this is the explicit, right? Recursive would be a to the 1 is 1250, a to the n is, whoops, sorry, I got to put the initial value, would be 0.8, our common ratio, times a to the n minus 1. And this would be my recursive formula. Now if I want to know the attendance after 10 years, I can plug it in. If I want to know we know the first year is 1250, so what is the 10th year? Well, it's going to be 1250 times 0.8 to the 10 minus 1. And then now I can solve. So this is really 9. So I got to do 0.8 to the 9th power. And then I can multiply that by 1250. And then after I round it to the nearest whole person, because we're talking about people, we can't round to the nearest hundredth, I'm going to get about 168. So attendance at this food festival will be about 168 in 10 years, given this decrease of 20% each year. Okay. I think that's it. Oh no, we got one more. Nice. Okay. So we have a company stock with a steadily decreasing value over the last week. We want to write an equation to determine the value of our stock in the future if it keeps losing value at the same rate. The dollar value of our stock each day was this. So here is your sequence. So what I want you to do is write a geometric sequence, but I want you to write the explicit formula of this sequence. So we're writing the explicit formula of this sequence, and we're just going to check it and see how you do. Okay, so pause it, write the sequence, go. Okay, so the first thing we need to figure out is what's that common ratio. Okay, so this is a good example because with these numbers, some of these have probably been rounded. Okay, so when I found my common ratio between these two, I got 95. But with these two, I got 0.94, and then it was like 999, and then it was something else. Okay, so this rounds to 95. Okay, so sometimes that common ratio is not going to be exact each time because it's already been rounded to get these decimals when we're dealing with money. So just be aware of that. But the common ratio is 0.95. So that means it's going down 5%, right? That's our growth, that's our decay factor. That is the common ratio. So if I write the explicit formula, our initial value is 1029. Common ratio is 95. That's to the power of n minus 1. And then we can figure out after n amount of days, or what the nth term is going to be based on how many days that go by, what the value of that stock is going to be. Okay, that's all I got for you guys. We're not going to do anything for things to remember today. Write the explicit and recursive formula for the sequence for your independent practice, and that is it. I hope this helped. If you have any questions, let me know. Gradius out.